Hi, welcome back to my class in trigonometry. For today, we will take up the values of the 6 trigonometric functions of the third special angle, 60 degrees. We consider again the equilateral or equiangular triangle we had in the last lesson. This is an equilateral triangle. All of the sides are congruent. And in the last time, we take the length of each side to be 1 unit. And from this equilateral triangle, we construct a right triangle by constructing a bisector of this angle, a perpendicular bisector through this angle through the midpoint of the opposite side. We locate the midpoint of this side opposite this angle. This perpendicular bisector of this side passes through the midpoint of this side. And because this is perpendicular to this side of the equilateral triangle, we form a right angle. Now we have the right triangle. And because the triangle is equilateral, it is also equiangular, which means that the three angles are congruent. So this is 60 degrees. And because this is the midpoint of this side of the equilateral triangle, whose length is 1 unit, then from this vertex of the triangle to this midpoint is 1/2. And from last time, we derived the length of this side of this right triangle by Pythagorean theorem, and we showed that the length of this side is square root of 3 divided by 2. Or that is by Pythagorean theorem, 1 square minus the square of 1/2, or 1 minus 1/4. That's 3 over 4, and you get the square root. You get 3 over 2. Now we are interested in the functions of 60 degrees. We start with sine of 60. We define from the previous lesson that sine of an angle, acute angle, such as 60 is equal to the ratio of the side opposite 60 divided by the hypotenuse. And from our diagram, the side opposite 60, this side of the right triangle has a length of square root of 3 over 2. Divided by the hypotenuse, the side opposite the right angle has a length of 1 unit. Divided by 1. Square root of 3 over 2 divided by 1 equals square root of 3 over 2. Thus, the sine of 60 degrees equals square root of 3 over 2. Next, we derive the cosine of 60 degrees. cosine is defined as the ratio of the side adjacent to the acute angle 60 divided by the hypotenuse. The side adjacent to 60 is the side of the right triangle that makes the acute angle 60 degrees with the hypotenuse. And the length of this side, adjacent side, the side adjacent to 60 is 1/2. Divide by the hypotenuse, the side opposite the right angle has a length of 1 unit. And 1/2 divided by 1 is 1/2. Hence, cosine of 60 degrees equals 1/2. Now we find the tangent of 60 degrees. Tangent of an acute angle is defined as the ratio of the side opposite the acute angle and the side adjacent to the acute angle 60, or tangent is equal to the ratio of opposite side and the adjacent side. The side opposite 60 has a length of square root of 3/2. Divide by the length of the side adjacent to 60 degrees has a length of 1/2. And to simplify this complex fraction, we multiply the numerator, square root of 3/2, by the reciprocal of the denominator, or reciprocal of 1/2. We have square root of 3/2 multiplied by reciprocal of 1/2, which is 2/1. And 2 will cancel out because 2/2 is 1. Square root of 3 divided by 1 is square root of 3. Thus, the tangent of 60 degrees equals square root of 3. From these values of the first 3 trigonometric functions of 60 degrees, we obtain the values of the last 3 trigonometric functions of 60 degrees. And we start with the reciprocal of sine is cosecant of 60 degrees. The value of cosecant of 60 degrees is the reciprocal of the value of sine of 60 degrees, or reciprocal of square root of 3/2. And the reciprocal of square root of 3/2 is 2 over square root of 3. And we rationalize the denominator to remove the radical sign from the denominator by multiplying 2 by square root of 3 and multiplying square root of 3 by square root of 3. Multiply the numerators 2 by square root of 3. And multiply the denominators, square root of 3 and square root of 3. By property of radical, they can be written as one radical expression, whose index of the radical sign is 2, because the common index is 2. Square root of the product of the radicals, 3 and 3. Square root of 3 times square root of 3 equals square root of 9. And square root of 9 is 3. And this is the value of cosecant of 60 degrees. 2 times square root of 3 divided by 3. Next, we find the value of the secant of 60 degrees. Secant is the reciprocal of cosine. Next, we find the value of the secant of 60 degrees. Secant is the reciprocal of cosine of 60 degrees. The value of secant of 60 degrees is the reciprocal of the value of cosine of 60 degrees. And the value of cosine of 60 degrees is 1/2. And its reciprocal is 2 over 1, or 2 divided by 1 is 2. Thus, the value of secant of 60 degrees is 2. Lastly, we find the value of cotangent of 60 degrees. Cotangent is the reciprocal of tangent. And the value of cotangent of 60 degrees is equal to the reciprocal of the value of tangent of 60 degrees, which is square root of 3. If you will write the denominator of square root of 3, its denominator is 1. And the reciprocal of square root of 3, or square root of 3 over 1, is 1 over square root of 3. One over square root of 3 is the value of cotangent of 60 degrees. But we rationalize the denominator to remove the radical sign from square root of 3 by multiplying the numerator 1 by square root of 3 and multiplying the denominator square root of 3 by square root of 3. In the numerator, we have 1 multiplied by square root of 3 is square root of 3. In the denominator, we have square root of 3 times square root of 3 by property of radical from your course in algebra. Can be written as a single radical expression whose index of the radical sign is 2, because the common index here is 2 for square root. And square root of 3 times square root of 3 is square root of 9, where 9 is the product of the radicants 3 and 3. Again, square root of 3 times square root of 3 by property of radical equals square root of 9. And square root of 9 is 3. This is now the value of cotangent of 60 degrees, square root of 3 over 3. Now, we take an example of finding the values of the 6 trigonometric functions of an angle that is a multiple of 60 degrees. Consider the following problem. Find the 6 trigonometric functions of 240 degrees. Draw the diagram. We draw the given angle 240 degrees in the Cartesian plane in standard position. In the Cartesian plane, we denote the horizontal axis by x, the vertical axis by y. And if we draw the angle 240 in standard position, its vertex is at the origin, and the initial side is on the positive side of the x-axis. Since 240 is a positive angle, we measure 240 from its initial side, or the positive x-axis, in counterclockwise direction. And 240 is divisible by 60. If you divide 240 by 60, you will get 4. 240 degrees divided by 60 degrees is equal to 4, which means that there are 4 60-degree angles in 240 degrees. So we count 4 60-degree angles from here, from the positive x-axis in counterclockwise direction. This is approximately 60 degrees, and another 60 degrees will be this angle. We have 60, 60. And or from the positive x-axis to the negative side of the x-axis, that's 180 degrees. And you subtract 240. You subtract 180 degrees from 240. minus 180 degrees. This means the difference is 60. That means from the negative x-axis, we continue to measure 60 degrees to get a total of 240 degrees. Or you may do this method. You divide 240 by 60 and you get 4. And you count 4 60-degree angles from the positive x-axis in counterclockwise direction. Like I was doing earlier, this is one 60-degree angle, and the remaining angle here is 30. Measure another 30, that's 2 60-degree angles, and this is the third 60-degree angle. And we need another one for the fourth 60-degree angle from this negative side of the x-axis, counterclockwise. This is 60-degree angle. This is the fourth of the 60-degree angle contained in 240 degrees. Now from the terminal side, this is now the terminal side of the given angle 240 degrees measured from the positive x-axis in counterclockwise direction. From the terminal side of 240 degrees, you take an arbitrary point. And to construct a right triangle, you drop a perpendicular from this point on the terminal side of 240 to the x-axis. And this is the right angle. As we did in the equilateral triangle earlier, we take the length of the hypotenuse equal to 1 unit. And in this diagram, the 1 unit is the distance of this point on the terminus side of the angle 240 from the origin. And the side adjacent to 60, as in our equilateral triangle earlier, is 1/2. And the side opposite 60 degrees, as in our equilateral triangle earlier, is square root of 3 over 2. Hence, this point on the terminus side of the angle 240 degrees has coordinates x is negative 1/2. The length of this side of the right triangle is 1/2, but the abscissa of this point on the terminus side of 240 is negative. We specify this is negative, and that's the value of x. The abscissa of this terminal of this point on the terminus side of 240 degrees. And the value of y, or the ordinate of this point on the terminus side of 240, is also negative because this point is below the x-axis. And square root of 3 over 2 is the length of this side opposite 60 degrees. But as coordinate of this point, we write negative. And this is the ordinate, or the value of y, of this point on the terminus side of 240 degrees. The negative sign here indicates that the point is to the left of the y-axis, and the negative here indicates that the point is below the x-axis. Now we are ready to find the 6 trigonometric functions of 240 degrees. And we start with sine of 240 degrees. We obtain the sine of 240 degrees using this right triangle with acute angle 60 degrees. Sine is defined as the ratio of the opposite to the hypotenuse. And opposite 60 degrees is negative square root of 3 over 2. Divide by the hypotenuse. The hypotenuse is 1. It is the radius vector 1. The radius vector is always positive. And negative square root of 3 over 2 divided by 1 is negative square root of 3 over 2. Next, we find the cosine of 240 degrees. Again, using this right triangle with acute angle 60 degrees. Cosine is defined as the ratio of the side adjacent to 60 degrees and the hypotenuse of the right triangle. Our cosine equals adjacent over hypotenuse. From our diagram, the side adjacent to 60 is negative 1/2. Divide by the hypotenuse. The hypotenuse is the radius vector with length of 1. And negative 1/2 divided by positive 1 is negative 1/2. We continue to find the other four trigonometric functions of 240 degrees. Next, we find the tangent of 240 degrees. Tangent is defined as the ratio of the opposite side to the adjacent side. From our diagram, using this right triangle with acute angle 60 degrees, the side opposite 60 is negative 3 over negative square root of 3 over 2. And we divide that by the side adjacent to 60 degrees, which is negative 1/2. And negative divided by negative is positive. And to simplify this fraction, we multiply the numerator, square root of 3 over 2, by the reciprocal of the denominator, or reciprocal of 1/2. We have square root of 3 over 2 multiplied by the reciprocal of 1/2, which is 2 over 1. Again, 2 over 2 will cancel out because it's equal to 1. And square root of 3 divided by 1 is square root of 3. We now have the values of the first three trigonometric functions of 240 degrees. And from these three values of the first three trigonometric functions of 240 degrees, we will obtain the values of the last three trigonometric functions of 240 degrees. The reciprocal of sine is cosecant. We find the value of cosecant of 240 degrees. And cosecant is the value of the cosecant of 240 degrees is the reciprocal of the value of sine of 240 degrees. The value of sine of 240 degrees is negative 3, negative square root of 3 over 2. And we take its reciprocal, it's negative 2 over square root of 3. But we want to rationalize the denominator. We want to remove the radical sign from the denominator. Hence, we multiply the numerator and denominator by square root of 3. Again, we rationalize the denominator, square root of 3. We multiply the numerator by square root of 3. And we multiply the denominator by square root of 3. Now multiply the numerator is negative 2 times square root of 3 is negative 2 square root of 3. In the denominator, we multiply square root of 3 and square root of 3. And we apply property of radical that says we can write this as a single radical whose radical sign has an index of 2, because the common index of these two square root is 2. And the radical will be 3 multiplied by 3, 9. Thus, square root of 3 times square root of 3 equals square root of 9, which is equal to 3. And this is the value of cosecant of 240 degrees. Negative 2 times square root of 3 divided by 3. Next, we find the reciprocal of cosine, which is secant of 240 degrees. The value of secant of 240 degrees is the reciprocal of the value of cosine of 240 degrees, which is negative 1 over 2. And the reciprocal of negative 1 over 2 is negative 2 over 1, or negative 2. Finally, the reciprocal of tangent is cotangent, and we find the cotangent of 240 degrees. The value of cotangent of 240 degrees is the reciprocal of the value of tangent of 240 degrees, which is square root of 3. Again, if you will write the denominator of square root of 3, its denominator is 1. And the reciprocal of square root of 3 over 1 is 1 over square root of 3. But we rationalize the denominator by multiplying the numerator 1 by square root of 3. And we multiply the denominator square root of 3 by square root of 3. We have 1 times square root of 3 is square root of 3. And square root of 3 times square root of 3 by property of radical is the square root of 9, where 9 is the product of 3 here and 3 here. And square root of 9 is 3. And square root of 3 over 3 is the value of cotangent of 240 degrees. We are done with the functions of special angles 30 degrees, 45 degrees, and 60 degrees. Now we will take quadrantal angle. A quadrantal angle is an angle whose terminal side coincides with one of the coordinate axes. The terminal side of a quadrantal angle can be the positive x-axis, the positive side of the y-axis, the negative side of the x-axis, or the negative side of the y-axis. Again, quadrantal angle is defined as follows. Quadrantal angle is 1, an angle whose terminal side coincides with the coordinate axis. That is, if you will construct the quadrantal angle in the Cartesian plane in standard position, the terminal side of a quadrantal angle lies or coincides with one of the coordinate axes. The quadrantal angles are 0 degree, 90 degrees, 180 degrees, 270 degrees, 360 degrees. All of these 5 are quadrantal angles, and all multiples of any of these is also a quadrantal angle. If you will construct 0 degree in standard position, its vertex will be at the origin, and its terminal side is at the positive x-axis. But since the angle is 0, the terminal side will coincide with the positive x-axis. And this angle represents the 0 degree, and 0 degree is a quadrantal angle because its terminal side coincides with its initial side, or the positive side of the x-axis. 90 degrees is also a quadrantal angle. If we construct the 90-degree angle in standard position, its vertex will be at the origin. Its initial side is at the positive side of x-axis, and its terminal side will coincide with the positive y-axis. This is the 90-degree angle, and it is a quadrantal angle because its terminal side lies on the positive side of the y-axis, or the terminal side of 90-degree angle coincides with the y-axis. 180 degrees is also a quadrantal angle. If we construct the angle 180 degrees in standard position, its vertex is at the origin, and terminal side lies on the positive x-axis, but its terminal side will lie on the negative side of the x-axis. This is the positive quadrantal angle 180 degrees. Its terminal side coincides with the x-axis, more specifically with the negative side of the x-axis. 270 degrees is a quadrantal angle. If you will construct the angle 270 degrees, its vertex is at the origin, or the point 0. Its initial side is on the positive side of the x-axis, and from the positive x-axis we measure 270 in counterclockwise direction. And you will find that its terminal side will lie on the y-axis, more particularly on the negative side of the y-axis. And this is the angle. This is the angle 270 degrees, and it is a quadrantal angle because its terminal side coincides with the y-axis. And lastly, 360 degrees is a quadrantal angle. If we construct 360-degree angle in standard position, its vertex is at the origin, and its initial side is on the positive side of x-axis, and from its initial side we measure 360 in counterclockwise direction, and the terminal side will coincide with the positive x-axis and also with its initial side. Hence 360 degrees. Hence the 360-degree angle is a quadrantal angle because its terminal side coincides with the x-axis, or more particularly the positive x-axis. Now we will find the 6 trigonometric functions of each of these quadrantal angles. And when we take a point on the terminal side of each of this quadrantal angle, we let the distance of this point on the terminal side of the quadrantal angle from the origin, the distance of that point from the terminal side of a quadrantal angle from the origin be equal to 1 unit. We start with 0. The initial side and the terminal side of the quadrantal angle 0 coincides with the positive x-axis. And from this terminal side of the angle 0, we take an arbitrary point 0. We take an arbitrary point whose distance from the origin is 1 unit. If the angle is an acute angle that is greater than 0 but less than 90 degrees, its terminal side will lie on the first quadrant. And we take an arbitrary point on the terminal side of this acute angle. We denote that by theta, whose distance from the origin is 1 unit. And as we customarily do, we drop a perpendicular from this point on the terminal side of the acute angle theta, perpendicular to the x-axis. The distance of this point from the horizontal axis or x-axis is the ordinate of this point, y. And the distance of this point from the y-axis, which is equal to this side adjacent to theta, is x. And we define the sine of theta as the ratio of the opposite to the hypotenuse, y over r. For the quadrantal angle 0, with terminal side that coincides with the positive x-axis, and this point on its terminal side, the coordinate of this point on the terminal side of the 0-degree angle is r, x. X has a value at this point on the terminal side of 0-degree angle. And because this point is on the x-axis, the value of y, or the ordinate of this point, is 0. But the distance of this point from the origin is equal to 1, the radius vector. Hence, this point with abscissa x is equal to 1, the radius vector. X is equal to 1 and y equals 0. Hence, for the 0-degree angle, for the quadrantal angle 0 degree, the value of the radius vector is 1, the value of x is 1, and the value of the ordinate is 0. And we define sine of the acute angle theta as the ratio of y over r, the ratio of the side opposite theta divided by the hypotenuse, r. For the 0-degree angle, y is 0. And the radius vector is 1. And 0 divided by 1 is 0. Hence, the sine of 0, if theta is the quadrantal angle 0 degree, sine of 0 degree is 0. Now we find the cosine of the acute angle theta. From this diagram, cosine theta is defined as the ratio of the adjacent side x and the hypotenuse. Or cosine of theta equals x divided by r. For the 0 degree, for the quadrantal angle 0 degree, x is 1 and the radius vector r is 1. And 1 divided by 1 is 1. Thus, the cosine of 0 is 1. Now, tangent, we find the tangent of 0 degree. First, we define the tangent of the acute angle theta as the ratio of the opposite to the adjacent. From this diagram, opposite theta is y, adjacent to theta is x. Thus, tangent of theta is opposite y divided by adjacent x. For the 0 degree angle, y is 0 and x is 1. And 0 divided by 1 is 0. Hence, the tangent of 0 degree is 0. And cosecant of theta is the reciprocal of sine of theta. The value of cosecant theta is equal to the reciprocal of the value of sine theta. And reciprocal of y over r is r over y. For the 0 degree angle, the cosecant of 0 degree is the reciprocal of sine 0. And the reciprocal of 0 is 1 over 0, which is undefined. Hence, the cosecant of 0 is undefined or not defined. The value of secant theta is the reciprocal of the value of cosine theta. Whose value is x over r. Its reciprocal is r over x. For 0 degree angle, the secant of 0 degree is the reciprocal of cosine of 0 degree. Cosine of 0 degree is 1. The reciprocal of 1 is 1. And secant of 0 degree is 1. Cotangent of theta is the reciprocal of tangent theta, whose value is y over x. And the reciprocal of y over x is x over y. That's the value of cotangent theta. For the quadrantal angle 0 degree, cotangent of 0 is equal to the reciprocal of tangent of 0 degree, which is 0. Tangent of 0 degree, tangent of 0 degree is 0, and reciprocal of 0 is 1 over 0, which is also undefined or not defined. Thus, the sine of 0 degree is 0, Cosine of 0 degree is 1. Tangent of 0 degree is 0. Cosecant of 0 degree is not defined. Secant of 0 degree is 1. Cotangent of 0 degree is not defined. Now we find the trigonometric functions of 90 degrees. We construct again 90 degrees in standard position. Its vertex will be at the origin. The initial side will be on the positive x-axis, and its terminal side coincides with the positive y-axis. And we take a point on the terminal side of 90 degrees. The distance of this point on the terminal side of 90 degrees we take to be equal to 1 unit. The distance of this point on the terminal side of 90 degrees from the origin, or the radius vector, is 1 unit. And this point on the terminal side of 90 degrees has coordinates. Because this point is on the y-axis, and the abscissa or value of x of any point on the y-axis is 0. And y has a value which is equal to 1. At this point, the value of y is 1, because the distance of this point from the origin is 1 unit, equal to the radius vector. Now we find, so for the quadrantal angle 90 degrees, r is 1, the value of x is 0, the value of y is 1. And as we start with sine of 90 degrees, sine is defined as the ratio of y over r. Y is 1, r is 1, 1 divided by 1 is 1. And sine of 90 degrees is 1. Now, cosine of an angle is the ratio of x over r, of x and r. X is 0, r is 1, 0 divided by 1 is 0. Tangent of 90 degrees equals y over x. Y is 1, x is 0, and 1 divided by 0 is not defined. Next, we have cosecant of 90 degrees. The value of cosecant of 90 degrees is the reciprocal of the value of sine of 90 degrees, which is 1. And the reciprocal of 1 is 1. Thus, cosecant of 90 degrees is 1. Next, we find the value of secant of 90 degrees, if it exists. The value of secant of 90 degrees is the reciprocal of the value of cosine of 90 degrees, which is 0. And the reciprocal of 0 is 1 over 0, which is undefined. Finally, we find the cotangent of 90 degrees. The value of cotangent of 90 degrees is the reciprocal of the value of tangent of 90 degrees, or the reciprocal of y over x, which is x over y. X is 0 and y is 1. 0 divided by 1 is 0. Now we find the trigonometric functions of the quadrantal angle 180 degrees. We construct again the quadrantal angle 180 degrees in standard position. The initial side, the vertex of 180 degrees in standard position is at the origin. The terminal side is on the positive x-axis. And from the positive x-axis, we measure 180 in counterclockwise direction. And the terminal side of 180 coincides with the negative x-axis. On the terminal side of 180 degrees, we take an arbitrary point whose distance from the origin or the radius vector is 1. And at this point on the terminal side of 180 degrees, the value, the x, the abscissa, the first coordinate of this point, x has a value. And because this is a point on the x-axis, the value of the ordinate y is 0. And the value of x is the distance of this point from the origin, which is equal to the radius vector. Hence, for the quadrantal angle 180 degrees, r is 1, x is 1, and y is 0. Now we find the sine of 180. Sine is y over r. Y is 0, r is 1. 0 divided by 1 is 0. And cosine of 180 is defined as the ratio of x and r. X is 1, r is 1. x1 divided by r1 is 1. So cosine of 180 degrees is 1. Sorry. You notice that this point is to the left of the y-axis. So at this point, the value of x is negative. And we write here negative 1. Hence, the value of x is negative 1. Because the point on the terminal side of the angle 180 degrees is to the left of the y-axis. And all the points to the left of the y-axis, the x-coordinates or abscissas or values of x are negative. The radius vector is 1, but the negative here, the sign negative of 1 indicates that the point x0 is to the left of the y-axis. Again, we find cosine of 180 degrees equal to x over r. X is negative 1 and r is 1. Negative 1 divided by 1 is negative 1. Thus, the cosine of 180 degrees is negative 1. Now, tangent is defined as the ratio of y and x. Tangent of 180 degrees equals y, 0, divided by x, negative 1. 0 divided by negative 1 is 0. Cosecant of 180 degrees is defined as r over y. Our r is 1, our y is 0, and 1 divided by 0 is not defined. Or cosecant is the reciprocal of sine. The sine of 180 degrees is 0. And reciprocal of 0 is 1 over 0, which is not defined. Now, secant of 180 degrees is r over x. R is 1. X is negative 1. 1 divided by negative 1 is negative 1. Or secant of 180 degrees is the reciprocal of the value of cosine of 180 degrees, which is negative 1. And the reciprocal of negative 1 is negative 1. Now, cotangent of 180 degrees is x over y. X is negative 1 and y is 0. Negative 1 divided by 0 is not defined. Or the value of cotangent of 180 degrees is equal to the reciprocal of the value of the tangent of 180 degrees, which is 0. And the reciprocal of 0 is 1 over 0, which is not defined. Next, we find the trigonometric functions of 270 degrees. We construct the quadrantal angle 270 degrees in standard position. So its vertex is at the origin. The initial side is on the positive side of the x-axis. And we measure 270 from its initial side in counterclockwise direction. And its terminal side will lie on the negative side of the y-axis. This is the terminal side of the angle 270 degrees. And we take a point, arbitrary point on the terminal side of 270 degrees. And we let the distance of this point on the terminal side of 270 degrees from the origin to be equal to 1. And we specify the coordinates of this point on the terminal side of the quadrantal angle 270 degrees. Because this point is on the y-axis, and any point on the y-axis has 0 abscissa or 0x coordinate, or the value of x at any point on the y-axis is 0. And y has a value. In particular, at this point, the value of y is 1 unit, negative 1. The value of y is negative 1 because the distance of this point, which is a point on the y-axis, from the origin is 1 unit. And because this point is below the x-axis, then the value of y is negative 1. Hence, for 270 degree angle, r is 1, x is 0, and y is negative 1. Now we find the trigonometric functions of 270 degrees. Sine of 270 degrees is equal to y over r. Y is negative 1, r is 1. Negative 1 divided by 1 is negative 1. Next, we find cosine of 270 degrees equal to x over r. At this point, x is 0, divided by r is 1. 0 divided by 1 is 0. Now, tangent of 270 degrees is y over x. At this point, y is negative 1, x is 0. Negative 1 divided by 0 is not defined. Next, we find cosecant of 270 degrees, defined as r over y. R is 1, and y is negative 1. And 1 divided by negative 1, r divided by y. 1 divided by negative 1 is negative 1. Or cosecant of 270 degrees is the value of the reciprocal of sine of 270 degrees, which is negative 1. And the reciprocal of negative 1 is negative 1. Next, we find secant of 270 degrees. And it's equal to r over x. R is 1 and x is 0. And 1 divided by 0 is not defined. Or secant of 270 degrees is the reciprocal of the value of cosine of 270 degrees, which is 0. And the reciprocal of 0 is 1 over 0, or not defined. Now, cotangent of 270 degrees is given by x over y, where x is 0 and y is negative 1. And 0 divided by negative 1 is 0. Now we find the 6 trigonometric functions of the quadrantal angle 360 degrees. We construct the angle 360 degrees in standard position. So its vertex will be at the origin. Its initial side is on the positive side of the x-axis. And from the positive side of the x-axis, we measure 360 degrees in counterclockwise direction. And the terminal side of the quadrantal angle 360 degrees will coincide with its initial side and also with the positive x-axis. From the terminal side of this quadrantal angle 360 degrees, we take a point whose distance from the origin or the radius vector is 1 unit. And this point on the terminal side of the quadrantal angle 360 degrees has coordinates x, 0. The first coordinate of this point, x, has a value. But because this point on the terminal side of 360 degrees is a point on the x-axis, the ordinate y is equal to 0. But this x, the distance of this point given by from the y-axis given by x, is equal to the radius vector 1. The distance of this point from the origin is 1, and that is the value of x. So for the quadrantal angle 360 degrees, r is 1, x is 1, and y is 0. We find the sine of 360 degrees. It's equal to y over r. Y is 0, r is 1. 0 divided by 1 is 0. Cosine of 360 degrees is given by x over r. X is 1, r is 1. 1 divided by 1 is 1. And tangent of 360 degrees is given by y over x. For 360 degree angle, y is 0, x is 1, 0 divided by 1 is 0. Cosecant of 360 degrees equals r over y. R is 1, y is 0, 1 divided by 0 is undefined. Or cosecant of 360 degrees is the value of the reciprocal of sine of 360 degrees, which is 0. And the reciprocal of 0 is 1 over 0, which is not defined. The secant of 360 degrees is given by r over x. R is 1, x is 1. 1 divided by 1 is 1. Or secant of 360 degrees is equal to the value of cosine of 360 degrees, which is 1. And the reciprocal of 1 is 1. Finally, the cotangent of 360 degrees is given by x over y, where x is 1 and y is 0. And 1 divided by 0 is not defined. Or cotangent of 360 degrees is the reciprocal of the value of tangent of 360 degrees, which is 0. And the reciprocal of 0 is 1 over 0. And 1 over 0 is not defined. So these are the 6 trigonometric functions of these 5 quadrantal angles. And you can, by inspection of this table, you can see that there are always 2 trigonometric functions for which the value of the quadrantal angle is not defined. For your practice, please try the following exercises. Find the 6 trigonometric functions of each angle. Number 1, 300 degrees. Number 2, 120 degrees. Number 3, 450 degrees. And number 4, 540 degrees. For each of these 4 given angles, you draw the given angle in standard position in Cartesian plane. The first 2 angles, 300 degrees and 120 degrees, are multiples of 60. Hence, when you find the trigonometric functions of 300 and 120 degrees, you will write the values of these trigonometric functions 300 degrees and 120 degrees in terms of the trigonometric functions of the acute angle or the special angle 60 degrees. The last 2 given angles, 450 degrees and 540 degrees, are quadrantal angles, which means that their terminal sides coincide with one of the coordinate axes. And when you take a terminal point on the when you take a point on the terminus side of 450 degrees or 540 degrees, you let the distance of this point on the terminus side of the quadrantal angle from the origin to be equal to 1. That means you let the radius vector be equal to 1. If you have question about the lesson today, please ask your question in the comments below. Don't forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and pleasure. Or ask your friends or your classmates to subscribe to my YouTube channel, Art Kalisan, so they may learn as well. Thank you for joining me in my class today.